हाय, मैं हूँ प्रीतम कुंडू और मैं आपको पढ़ाऊंगा मैथमेटिक्स। एंड टुडेस टॉपिक इज रिलेशन एंड फंक्शन। टुडेस टॉपिक रिलेशन एंड फंक्शन. We started about set. The first question is what is set? The set is a collection of well-defined and distinct objects. So first, what is set actually? A collection of well-defined, distinct objects is called set. So first question has two words. First well defined and second is distinct. First, what is well defined actually? Well defined means there is no ambiguity about an element that is include or exclude in a set. That is, if I say 4 months of a year, then I say January, February, March, April, and another person says March, April, May, June. Then there is an ambiguity. What is the set actually? So well defined means there is no ambiguity. Actually, if I say first 4 months of a year, then there is a correct and distinct. There is no repetition about element in a set actually. So this is called distinct. Example: A is a set collection of vowels in English alphabet. Then what is this actually? A, E, I, O, and U. That is the set actually. Then the notation is this: A belongs to capital E, E belongs to capital A, and etc. Actually, this is our set. And the next topic is what is Cartesian product? Two set A and B and their Cartesian product. So the next topic is Cartesian product. That is Cartesian product. Two sets A and B and their Cartesian product is defined as A cross B equal to A comma B plus that A belongs to capital A and B belongs to capital B. Here is your Cartesian product of two sets A and B, and the Cartesian product A cross B, that is A comma B, is an ordered pair where the first element comes from the first set and the second element comes from the second set. And our next topic is power set. What is power set? Collection of subset of any set of A is called power set. That is actually collection of any collection of subset of any set A is called power set and denoted by P of A. And that is about the element. If a set contains n element, then its power set contains 2 to the power n element. That is actually, what is this? That is, if a set contains n element, then its power set contains 2 to the power in elements actually. Okay, then so that is your set Cartesian product and this is your power set. And then next our main topic is comes from this relation. What is actually relation? Then what about the relation actually? This is a relation. So a relation from A to B is a subset of A cross B. That is, if R is a relation from A to B, then R is a subset of A cross B. Then I have some example actually. If I say A comma B belongs to R, this means A is related to B. If A comma B does not belong to R, this implies A is not related to B actually. Right? Okay? What is relation? A relation from A to B is a subset from A to B is a subset of A cross B. That is, if R is a relation from A to B, then R is a subset of A cross B. And if A comma B belongs to R, then A is related to B. And if A comma B does not belong to R, then A is not related to B. This is a relation. And what is the type of relation actually? Then what is the type of relation? There is three type of relation actually. Okay. So first of all, reflexive relation, and second is symmetric relation, and the third is transitive relation. So first, reflexive. Second, symmetric. The third, transitive. Okay. So first of all, it's reflexive relation. What is reflexive relation? If A set A, if I say about reflexive relation, so first of all, it's reflexive. If for all A belongs to capital A, this implies A comma A, this ordered pair belongs to R, then R is called reflexive relation. Okay? So actually what is reflexive relation? If this element A belongs to capital A, that is a set, then this implies this ordered pair A comma A always belongs to R. This R is called reflexive relation. And then our next topic is symmetric relation. If A comma B, this ordered pair belongs to R, and this implies that its opposite, that is B comma A, belongs to R, then R is called symmetric. And the next topic is transitive. So what is transitive? If A comma B and B comma C belongs to R, this implies A comma C belongs to R. This R is called transitive. This is a three type of relation. First of all, reflexive relation. What is reflexive relation? If a element A belongs to capital A, this implies A comma A belongs to R. Then R is called reflexive relation. And the second is if A comma B belongs to R, then B comma A also belongs to R. This R is called symmetric relation. And the third, if A comma B and B comma C. These two ordered pair belongs to R. Then its combination, that is A comma C. This belongs to R. Then R is called actually transitive relation. That is a three type of relation actually. And the next topic is function. So next topic is what is function actually. So function, a function if from a set A to a set B is a rule. Okay? What is function? A function f from a set A to a set B is a rule that assigns each element of A to exactly one element, of B. That is, what is function actually? A function f from a set A to a set B is a rule in which each element of A exactly one element of B, that is assigns. Okay, so diagram, if this is a set A and this is a set B, then that is a function A from A to B. If there is the element, this 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 the element. So each element exactly assigns. Okay, so no element this side can be left out. Each element can be mapped with this. So this can be mapped, this can be mapped, this can be mapped, this can be mapped. Okay, no one should be left out. So it should be mapped with some element. Okay, then this is the first point. Each element of A and exactly one element of B. This means if I say this map, these two elements, this is not a function actually. So exactly one element, exactly means with a one element. This is actually function. So what about the function? A function if from a set A to a set B is a rule that assigns each element of A with a exactly one element of B. That is actually function. So no element in this set A should be left out, and there is a one element. This is exactly one element in this set. So what is the notation about f is a function from A to B. This A set should be called domain. Okay, this A set is called a domain, and this B set is called a codomain. And there is another term is called range. Question, what is range? Okay, so first we define f of a. What is f of a actually? This f of a actually, this is the f of a such that a belongs to capital A, and this f of a is called a range set of this function. This is called range of this function. Okay, and that should be always f of a is a subset of our codomain set. This is your range set and this is your codomain set, and f of a is always a subset of our codomain set. So let's note actually what is the relation? Relation क्या था? Relation is just subset of a cross b, but function is also a subset of a cross b. But there is some restriction in this set of function actually. So all the relations are not function, but all the functions are relation. So note, take note. What about the note? That is all relations are not function, but all function are relation. This is the main point. Okay, so all relation are not function, but all the functions are relation. Okay, next diagram. This is the whole set of relation actually. Yeah, it's the whole set of relation, and this is the sum set function actually. So all the function is a relation, but all the relation are not a function. This is a very important note actually. Okay. The next topic, type of function. What are the type of function? Okay. So the type of function. Just diagram this. This is a function with a from A to B. So the type actually. First of all, one is one two one, and the second many two one, and the third one two, and the fourth is into function. So not equal. So there is four type of function: one to one, many to one to, and into. So first topic is one to one function. Okay. What is actually one-to-one function? A function if from a set A to B is called one-to-one function if each element of this first set, that is domain set A, exactly map with distinct element of B. Right? So that is actually if A1 and A2 are two distinct elements from A, then if A1 is not equal to A2, this implies f of A1 is also distinct with f of A2. So what is actually f of A1 and f of A2? F of A1 is the image of A1 and f of A2 is the image of A2. So now just if f of A equal to B, then B is called the image of f, and sorry, B is called the image of A actually under F. Okay, this is actually f of A equal to B. Then B is called the image of A under A. So what is f of A1? F of A1 is the image of A1 under F, and what is f of A2? That is the image of A2 under F. So diagram actually, if this is your set A and this is your set B, this is A1 and this is A2 and this is f of A1. So if this is the element, if this map with A1 map with f of A1, then A2 cannot be mapped with this element. So this is actually one to one say if A1 map with f of A1 and the distinct element A2 cannot map with this f of A1. So that is A2 will map this function f of A2. So this is the function if is one to one or this odd element that is injective map. So this is actually called one-to-one map from A to B or a injective map if for each distinct element of A that is the exactly distinct image in the set B, and if the set is this A and this is B, if this is A1 and this is A2, then if this is map with these two elements, this goes to this, that is f of A1 and f of A2. This is not actually a one-to-one function. So this is not a one-to-one function because of these two distinct elements map with the same element. So this is not a one-to-one function, but this is actually one-to-one function. Okay. So our next is many-one function. Okay, or many-to-one function. So our next topic is many to one. So if a function f from a to b is said to be a many one function if there is at least two elements, there is at least two elements in the set A which map one element in P. Then this set F is called many to one. That is, if F is a function from A to B, and in this set A there is at least two elements such that this map with one element in B. That is the example of this set actually. There is two elements A1 and A2, distinct two elements. This map with exactly one element in this set B. In this set D. So this is actually a map either one to one or many to one. So this is actually one to one map and this is actually many one map. So this is our say in which this is actually many one map. Actually many one set. Okay. And our next topic is onto. What is onto map? Which on two. So what is onto? A map if from A to B or a function actually. We say about a function. A function if from A to B is called onto if f of A is a subset or f of A is actually equal to B. That is, look at. Okay. So here is our onto function. A function if from A to B is said to be onto if for all element p belongs to P, there exists at least one A belongs to A such that f of A is equal to B. So, a onto map, what is actually onto map? A function f from A to B is said to be onto if for each element of this codomain set there exists at least one pre-image of a set A such that f of A is equal to B. That is a diagram. If this is your set A and this is your set B, then for each element B there is a pre-image. Okay, this set or this set. Sorry, this is not a map actually. This set. Leave this map to this. Okay, this is actually not a map. If there is no element in this set B should be left out actually. For each element there is a pre-image, and this is called actually an onto function. That is, if it's the range set f of A is equal to this codomain set. This is called actually onto map. If there is one element which is left out, then this map should not be onto. As example, if actually this and this is the three element and there is four elements also. But this map to this map to this map to this, and this map to this. So there is exactly this element which there is no image in this set, but there is no pre-image in this set. So this map should not be onto, but this map should be onto actually. Okay, and this map, this is actually not onto, so this map is into map. So what is actually into map definition? That is the last definition of this class actually. What is into map? What is into? A function if from A to B is said to be into if at least one element in this B set, extra one element which is no pre-image in this set, and this map is called into. If this is our B element in this set B, so there is no A for which this map to this actually. So this is our into map, and in this case, this range set is a properly subset of a set B, and this is our actually case. This is our into map. So one map or one function is either one to one or many to one or one to or n. So there is two type of function, that is which is a map each one to one and or many to one or either one to or into. If there is last, there is actually bijective function. A function, what is your bijective function or bijective map actually. What is bijective? A function if from A to B is said to be bijective if it holds two conditions. First of all, this if is injective or one to one, and the next case is if is one to or surjective. So a function is said to be bijective if it holds these two conditions, if it is injective or one to one, and if it is one to or surjective. That is the diagram of a bijective function. Here, this is set A and that is set B. Okay, and this is set A, this is set B. If there is four elements, it is 1, 2, 3, 4, and there is four elements. If this map with this map with this map with this, and this map with this. Okay, and it is in that A. Such that for each element there is a distinct element in this set B. So F is injective, and also for each element in this set B there is a pre-image in this set A. So F is also surjective. So this means F is also injective and also surjective. So this F is called bijective map. This is our today's topic actually, relation and function, set, Cartesian product, power set. The last topic is bijective function. So this is our topic today's class. Okay, thank you.